Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake, and second, have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components, and we are ready to go and crack the password. To do this, Aircrack-NG is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong, and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the passwords for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt, and I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run Aircrack-NG, so we're going to type the name of the program as usual, followed by the name of my capture file, which is WPA handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with a -w option, and the name of my word list is test.txt. So very simple. Aircrack is the name of my program. WPA handshake01.cap is the name of the file that contained my handshake, and I'm using -w to specify my word list file. I'm going to hit enter. And as you can see now, Aircrack-NG is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information on the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file, so if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's almost the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attacks section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to Aircrack-NG. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password.
In the previous lecture, we covered how to store our progress when going through a large word list. This allows us to pause and resume so that we can stop our cracking session and then come back at a different time and then start the session from where we left, which is very handy when we have a large word list. Another issue that we might face when you're using a large word list is the disk space. So a large word list would basically just take a lot of space from our disk. The solution to this is to generate the word list using Crunch and pass it on the fly to Aircrack-NG. So basically we're going to be using Crunch to create the word list like we've seen before, but instead of saving the word list on disk, we're going to make it produce the word list on screen. So the result is going to be very similar to what we got when we opened our word list with John the Ripper in the previous lecture. And then we're going to pipe that output to Aircrack-NG, which will read that as input and process the word list on the fly as it's being generated on Crunch. This way the word list will not be stored in a specific file and it won't take a lot of disk space. Now let me show you how to do that and it's going to become more clear. So first of all, before I do the whole command, I'm just going to show you the command that we usually use with Crunch. So we usually do Crunch, and then we do the minimum number of characters followed by the maximum number of characters. And I'm going to set both to 8 because this is the minimum number of characters that you can use in a WPA password. Then we usually specify the characters to use to generate the word list. Now I'm not going to specify any characters right now because I want to use all the characters. So if I don't specify any characters, Crunch will use A, B, C, D, E, F, G all the way up to Z by default. So all I have to do now is just do -O to specify the file to save the word list to, and let's just save it to all.txt. Now I'm going to hit enter. And as you can see, this file is going to be huge. It's going to be 1 terabyte, 1750 gigabytes, and this much megabytes. So it's going to be a huge file, and I actually don't have enough space on my disk to store that file. So I'm going to do Control-C. And what I'm going to do right now is I'm going to run the same command, and I'm just going to omit the -O argument. So what I'm doing right now is Crunch. I'm telling it that I want you to generate passwords of length 8. And I didn't specify any characters because I wanted to use all characters, A to Z. Now, if you want to use specific characters, you can just type them in here, A, B, C, D, E, F, G, 1, 2, 3, as I showed you before. So I'm going to hit enter with this. And you'll see that it's still telling me that this is going to take 1 terabyte, 1750 gigabytes, but it's displaying the result on screen. It's not storing it in a file. And if we let this run for a long period of time, it'll actually display all possible combinations of characters that have a length of 8 characters and contain the characters A to Z. Now I'm going to do Control-C to this because this is not useful for me. I'm just doing this to show you. But if you notice, the output right now is very similar to the output that I got in the previous lecture when I opened my word list using John the Ripper, when we were doing the pause and resume process. So you can see that the result is being displayed on screen for me now, which is very cool. So what I want to do right now is I want to pipe this result. So we usually pipe using this character like we've seen before. So what I want to do right now is I want to pipe the result of this command to Aircrack-NG. And like I said earlier, this command is producing a result very similar to the result that we got from John in the previous lecture, which means the output right now is exactly the same output that we got from John in the previous lecture. So the command that we're going to be passing this to can be exactly the same command that we used in the previous lecture, and it should work. Therefore, all I'm going to do is I'm going to do Aircrack-NG, and I'm going to give it the BSS ID of my target network. Then I'm going to give it -W to give it the word list. And just like I did in my previous lecture, I'm going to do a dash to tell it that use the output of the previous command as the input for the word list. Then I'm going to give it the handshake file, which is called handshake01.cap. And that's it. I'm good to go. So we're doing a crunch 88 to generate passwords of length 8 from A to Z. And again, you can use any crunch command right here. You can use any combination, any characters, any pattern, exactly the same way that I showed you in the crunch lecture. Then we're not using a -O option because we don't want it to save anything on disk. We want the result to be displayed on screen. And then we're piping that result to Aircrack-NG. Now to Aircrack-NG, we're giving it, I actually should not have a space here. So we're giving it the BSS ID of the target network. We're giving it the dictionary, and we're not actually giving a name for the dictionary. We're only giving it a dash. And this is because we're telling it that I want you to use the output of the previous command as the input. So this is exactly like we did in the previous lecture. And then we're giving it the file that contains the handshake. Now if I hit enter, I misspelled aircrack, so it's like this. Now if I hit enter, and as you can see now, Aircrack-NG is working. It's taking the passwords generated by Crunch on the fly and using them as the dictionary. So the word list is not being stored on my disk. My disk will not get full, and this way we'll be able to use huge word lists for cracking. The only problem right now is this word list is really big, and there is no way we can go through it within one session. So it'll be great if we can save our progress and be able to stop and continue whenever we have the time. So in the next lecture, I'm going to show you how to combine what we learned in this lecture and in the previous lecture so that we can use a huge word list and use it directly with Aircrack-NG without saving it on disk, and also be able to stop and resume our progress. Our next video is saving cracking progress when using huge word lists without wasting storage. Thank you.